Hello and welcome. This is NCEA in New Zealand, Intro to Calculus, Assignment 10B. Take a good look at this picture right here. Feel free to pause the screen and we'll go through this question first. Okay, it's time for a story. Question number 1. A small high country station in central Otago is concerned about the number of goats they are beginning to see on the property. The graph below shows why the number of goats on the property X years after the station first became concerned in the year 2000. Make sure that appropriate units are on all your answers. That means our units are goats or increase in goats per year. The first one, A. What was the number of goats when the station first became concerned in 2000? As we can see, it's right below that 50 mark. So anything from 48 goats, 49 goats, something in that neighborhood, that will be just fine. A tangent line has been drawn where x equals 2. That's this line right here. Estimate from the graph the number of goats at this point. At this point, you can see it's about 2/3 of the way between 50 and 75. 2/3 of 50 to 75 would put us at about 67 goats right there in the year 2002. Calculate the gradient of the tangent line to the curve at this point. So to find the gradient, we need 2 points. We know this point, 267. And we need one other point. For convenience, I've chosen 10,147. So now we have to find the slope. So let's go 147 minus 67 divided by 10 minus 2. This equals 80 over 8 equals 10. And the units of this 10, what it means is that in the year 2002, the population of goats is growing by approximately 10 goats per year. D. Write a sentence that summarizes what you know about the number of goats at this moment in 2002. Include the time elapsed, the number of goats, and the rate at which the population is changing. We know it's 2002. It's been 2 years since they became concerned about goats, and the population is at 67 goats, and it's increasing at the rate of 10 goats per year. Next, draw your own tangent at the point where x equals 7. So that's this one right here. And I've chosen another point that it'll go through. It will go through the point 250 right there. See how if we draw this line, it only goes through that graph at that point. So here, our main thing is we have this number here, 250, and then this, which I've estimated at 7 and approximately 140. Note that all of these calculations are approximate because of the ill-defined nature of this graph. So estimate the number of goats at this point. Approximately 140 goats. Calculate the gradient of the tangent to the curve at this point. 140 minus 50 divided by 7 minus 2 equals 90 over 5 equals 18. That's the slope, is 18. Write a sentence that summarizes what you know about the number of goats at this moment. Include the time elapsed, the number of goats, and the rate at which the population is changing. This is the year 2007. It's been 7 years since they've been concerned about the number of goats. They're currently at 140 goats. That population of goats is growing at a rate of 18 per year. And here you can look at the question one more time. Here is question number 2. It's a parabola, and you can see where all those points are. I'm not going to draw the parabola, but I'll perform all of the calculations. Question number 1. Show that the point -4, 8 lies on the curve. So what we do is we plug in our 8 right here. We say 8 equals -4, which is plugged in, squared plus 2 times -4. That means that 8 equals 16 minus 8. That is true. This point, -4, 8, lies on the curve. 2b. If Q1 is the point -4, 8, calculate the gradient of PQ1. So we plug everything in. Let's go, this one is 2, this one is 1. So we'll go 8 minus 3 divided by -4 minus -3. That equals 5 divided by -1, which equals -5. Our next point, Q2, is -3.5, 5.25. Calculate the gradient between this and this. So we go 5.25 minus 3 divided by -3.5 minus -3. This equals 2.25 divided by -0.5. That means that we have to double this and make it negative, which means -4.5. Question 2d. If Q is the point on the curve where x equals -3.1, calculate the gradient of PQ3. Note, you will need to calculate the coordinates of Q first. So here's what we do. We know that x equals -3.1, so we plug that in here, and we're trying to find y. Y equals -3.1 squared plus 2 times negative 3.1. 3.1 squared is 9.61. And 2 times negative 3.1, that's negative 6.2. This tells us that y equals 3.41. This is our point. Y equals 3.41. So now we have to work out the gradient. So we do 3.41 minus 3. That is 0.41. And then negative 3.1 minus negative 3. That is negative 0.1. As you can see, this is negative 4.1 is the gradient between these 2 points. The next part says, estimate the gradient of the tangent at P, the point negative 3, 3. And what we can see is as we started farther away from it, up here we got the value of negative 5. Then we got negative 4.5, negative 4.1. So the only thing we can assume is that we are getting closer and closer to negative 4. That's what we're getting closer and closer to. Question number 3. If y equals x squared plus 2x, show that the gradient of the tangent to the curve at the point negative 3, 3 is negative 4 by using differentiation. I'll use the definition of the derivative, also called first principles. So I'll just write the definition really quick. I'll just write the definition of the derivative really quick. F prime of x equals f of x plus h minus f of x divided by h as h approaches 0. So what we'll do here to find f of x plus h is we go x plus h squared plus 2x plus h. That's our f of x plus h. Then we have to subtract f of x. So minus x squared minus 2x. And we have to divide all of that by h as h approaches 0. This becomes x squared plus 2xh plus h squared plus 2x plus 2h minus x squared minus 2x all over h. Now we can see x squared minus x squared. These cancel out. Plus 2x minus 2x. These cancel out. So what we're left with, 2xh plus h squared plus 2h divided by h. This h cancels. This h squared becomes h, and this h cancels. So we're left with 2x plus h plus 2. Now what happens with this h is this approaches 0, so we can just put a big 0 in there, and we'll get our derivative is 2x plus 2. Now, as we plug in negative 3 for x, we get 2 times negative 3 plus 2, and this equals negative 6 plus 2, negative 4. We have proved that the derivative of x squared plus 2x at this point, negative 3, 3, equals negative 4. For question number 4, I'll just teach you the power rule really quick. I won't derive it, I'll just state it, which says that if you have x to the n, and you want to take the derivative of it, so what we do is we go like this, d over dx. We want to take the derivative of x to the n. This is n times x to the n minus 1. This is what we'll be applying for these questions right here. So we have our first one. It says y equals negative 3x plus 7. The derivative of a constant, so any number, the derivative is 0. Negative 3x, this is negative 3x to the 1. So the 1 comes in front. And this becomes negative 3 times 1 times x to the 0. X to the 0 is 1. This becomes negative 3. Part B, y equals 4x to the 9. So we'll separate this 4 for the moment. This 9 comes out in front, x. This 9 becomes an 8. So this becomes 36x to the power of 8. About this one, y equals 5x cubed minus 2x squared plus 4x minus 5. This 3 comes in front, that becomes 15x squared minus, this 2 comes in front, 2 times 2, minus 4x plus, this x just becomes a 1, so 4. 15x squared minus 4x plus 4. And our last one, y equals x minus 2 squared. So we distribute it. Y equals x squared minus 4x plus 4. Now we differentiate it. This 2 comes in front. 2x to the power of 1. So 2x minus 4. That is question number 4. Question number 5. Sketch the graph of f prime of x, given f of x. Here's what we'll do. We need to identify where it's flat. As you can see, it's flat right along here, and it's flat right here. So what does that mean about the derivative? The derivative will be 0 here, and it will be 0 here. The other thing to note is that here it's increasing. See, it's going from here, it's going up. That means that the slope is positive all the way until it hits 0. Then from here to here, you can see the slope is negative, but here it goes back to 0. So we have to do something like that. And then after this point, it just shoots straight up and off to the right with a positive slope from here on out. So it looks something like this. Now if you want to graph it on its own, simply go like this, and there you have it. Remembering the most important points, right here and right there, where this has a maximum and a minimum. This is what you need for optimization finding the maximum, finding the minimum. Question 6. Consider the function f of x equals x cubed plus 5x. Let P be the point on the curve where x equals -2. Calculate the coordinates of the point P. That means we take this -2 and plug it in for x. That gives us -2 cubed plus 5 times -2. -2 times -2 times -2, this becomes -8 plus -10, this equals -18. So P is -2, -18. And the next part, calculate the gradient of the tangent to the curve at the point P. So what we'll have to do is we'll have to take the derivative. So the derivative of x cubed, we move the 3 out in front, 3x squared plus 5 is the derivative. Then we plug this -2 in for x. So that becomes 3 times -2 squared plus 5. 3 times 4 plus 5 equals 17. 17 is our gradient. Question 7. Calculate the coordinates of the point on the curve y equals 4x squared minus 2x minus 3, where the gradient of the tangent is -10. Here's our function. We need to find our derivative. Y prime equals 8x minus 2. Now we know that the gradient is -10. We just don't know where. So we'll plug -10 in right here. -10 equals 8x minus 2. Now we add 2 to both sides. That gives us -8 equals 8x. What we know is that x equals -1. Now we just need to find y. What we do is we plug -1 into this right here. 4 times -1 squared minus 2 times -1 minus 3. And this is what our y is. This becomes 4 times 1, which is 4, plus 2. -2 times -1 is 2, minus 3. 4 plus 2 minus 3 equals 3. -1, 3. That is where our gradient is -10. Question number 8, our final question of this assignment 10b. If h of t equals 4t cubed plus 12t minus 4, calculate h prime of t. So this whole assignment we've usually been dealing with x. This deals with t. They're almost the same. Basically, x is more of location. T is usually referring to time. But with respect to how we differentiate, there's no difference. So we'll use the power rule. This 3 comes out in front. 3 times 4, that's 12t squared plus 12. That is our derivative of h of t. 12t squared plus 12. And this assignment is finished.